Welcome back to the HiSeq Expert Video Tips series. This video focuses on tips and troubleshooting guidance related to the HiSeq Instrument computer. If you have not already done so, be sure to check out Part 1, which discusses the appropriate sequencing primers for your HiSeq run. One of the most common error messages we see during HiSeq initialization is related to the computer communication ports. The HiSeq instrument integrates Fluidic systems with valves and pumps, mechanical stages with motors, thermal systems, optics, and computer components when generating DNA sequence data. All of these components need to communicate with a central HiSeq control software, and any communication disruption may cause an initialization error. When communication ports are closed improperly by the software, new communication can be claimed by the incorrect port number. After a communication port is claimed, it reconnects in the same order with a simple restart of the computer. An incorrectly connected communication port prevents the HiSeq control software from communicating with the subsystem normally allotted to that port, which would cause an initialization failure. To correct this, we can use a program called Port Manager, which can release all existing communication port connections. When your instrument PC is restarted, all communication ports will reestablish in the default configuration, usually resolving any existing communication disruptions. Here's how to use Port Manager. Close HiSeq control software and open the Port Manager program. Turn off the HiSeq. Right-click the Port Manager EXE and select the Compatibility tab. Check the Run this program in Compatibility Mode 4 box. Then select Windows XP Service Pack 2. Right-click the portmanager.exe file. Select Run as Administrator. Click Port Manager to open the program. COM1 is a physical port on the PC. COM2 is not used. COM3 to 4 connect to the HiSeq cameras. COM5 through 23 are virtual connections claimed by devices when the HiSeq turns on. Select each communication port and click Remove Device until all COM ports have been deleted and the box is empty. Click Apply, then OK, then close Port Manager. Restart the computer and wait until boot up is complete. This may take a few minutes. Turn on the HiSeq. Wait 2 more minutes to allow all ports to enumerate properly. Confirm the Do Not Eject drive is populated in Windows Explorer. Launch Port Manager and confirm that all 23 COM ports are re-established. Launch HCS to initialize the HiSeq. Another strongly recommended best practice is to format D and E hard drives on the HiSeq Instrument PC before starting a run. After first confirming data from previous runs has been successfully transferred to a permanent storage location, such as a network server, you can quick reformat the drive as needed. A clear hard drive at the start of a run ensures adequate temporary storage space for normal sequencing data acquisition and processing. It also ensures space is available to store run data if a network connection is lost. To format the drives, from Windows, open Computer to show the list of drives on the computer. If working with the D drive, move any files still needed to the C drive, specifically Illumina maintenance logs if present. Right-click the D or E drive and select Format. D is for data generated from flow cell position A. E is for data generated from flow cell position B. From the Format dialog box, select the Quick Format checkbox. Select Start. Important log files are stored on the C drive that, along with the Do Not Eject drive, should never be formatted. So it is okay to perform these steps while the instrument is performing a wash. If disk space drops below the safe threshold during the run, the software may pause the run and place the flow cell in a safe state. After disk space is made available, the run resumes automatically. However, this increases the overall run time, leading to inconvenience and delays, so it's best to format the appropriate drive before each run. Now let's go back to Tim for some best practices for setting up multiple runs.
Thanks, Chad. When staggering runs started on flow cell A and flow cell B, setting up a new run automatically pauses the current run on the adjacent flow cell. The flow cell currently running is placed in a safe state by the control software, allowing you to set up the sequencing run for the second flow cell. Illumina recommends setting up the second flow cell while the currently running flow cell is in a chemistry step. This prevents any difficulties that may occur when stopping the process mid-imaging. After loading the sequencing flow cell for the new run, close the compartment door and select Start to begin the new sequencing run. Make sure that the original flow cell has automatically resumed running. If it has not, select Resume manually. You can also manually stop the current flow cell. To do this, choose Normal Stop and End of Cycle to allow the instrument to finish its current process and place the flow cell in a safe state. When prompted for RTA option, choose Keep As Is to ensure that you can restart the flow cell right where you left off. Avoid selecting any RTA Complete option, as this is permanent and the process cannot be restarted. See the Stop and Resume a Run section of your instrument system guide for more details on the options.
These are a few computer-related best practices for streamlining your sequencing runs. Up next in the HiSeq video series, we will discuss HiSeq mechanical and thermal systems, as well as some maintenance and best practices.
We'll see you in part 3.